differentiation, and we continue with the quotient rule. Hit pause, copy the lesson objective down. When you're ready, hit play again. Okay, so we use the quotient rule where we have two functions and one's divided by the other, such as if you have y is equal to f of x over g of x, or more commonly we tend to write y is equal to u over v, where u and v are functions of x. So hit pause, copy some notes down. This is a type of function we're going to be differentiating, u over v. When you're ready, hit play again, and we'll look at how we differentiate them. Right, so if we have these functions, u over v, we've got y is equal to u over v, then its differential, dy over dx, is given by v times du over dx, the differential of u, minus u times dv over dx. That's all divided by v squared. And this is the most common form you'll use. However, if you had y is equal to f of x divided by g of x, then we can say dy over dx is equal to g of x times the differential of the numerator, so f dash of x, minus f of x times g dash of x, all divided by g of x, all squared. This is the most common form you'll use. You use this form in the main. However, in the exam booklet, this is the version you'll be given. So hit pause, make some notes. When you're ready, hit play again, and we're going to look at an example. Okay, so in our example we've got here, we've got y is equal to x divided by 2x plus 5. We want to find its derivative. So let's do that here. Y is equal to x divided by 2x plus 5. So we can say let u, the numerator, be equal to x, and v is going to be equal to 2x plus 5. So if we differentiate du with respect to x, we get 1, and if we differentiate v with respect to x, differentiate 2x, we get 2. And so our formula, d over dx for u over v, is given by v du over dx minus u dv over dx, all divided by v squared. So now we've got that, we can substitute for what we know. I'm going to change that u over v to y, makes it easier. Is equal to v, 2x plus 5, times du over dx, which is 1, minus u, which is x, times dv over dx, which is 2, all divided by v squared, which is 2x plus 5 squared, all squared. So that's equal to, we expand out, then we simplify, 2x plus 5 times 1 minus 2x, all divided by 2x plus 5 squared. Now the 2x's in the numerator cancel each other out. 2x minus 2x, so we end up with just 5. Oops, why have I got a highlighter? Just want a pen back. Red pen, even better. So you end up with 5 divided by 2x plus 5 squared. And that's us done, all differentiated. So what I want you to do, I'll just change that, it's a bit messy, is to hit pause in a second. Copy the example down. When you're ready, hit play again, and we'll look at another example. Okay, so let's have a look at this example. Got a curve C, and it's got an equation. It's given by y equals sine x over e to the 2x from 0 to pi. The curve has a stationary point at P. Find the coordinates of P. So 3 significant figures. It's got a stationary point, and we know something about the gradient at the stationary point. That implies that dy over dx is equal to 0 at the stationary point there. So we need to differentiate that and set it equal to 0. So let's do that. We got y is equal to sine x all over e to the 2x. I'm just conscious of space because we've got quite a lot to do. Right, so let's say let u be equal to the numerator and v be equal to e to the power of 2x. So we differentiate with respect to x. The u over dx is equal to cos x, and the v over dx is equal to 2e to the power of 2x. Now we've got our formula, d over dx, for our quotient, u over v, and that's given by v du over dx minus u dv over dx, all divided by v squared. So let's sub dy over dx is equal to v is e to the power of 2x times du over dx, which is cos x, let's put in brackets, minus u sine x times dv over dx, which is 2e to the power of 2x, all divided by v squared, e to the power of 2x squared. So let's simplify. So we've got e to the power of 2x cos x minus 2e to the power of 2x sine x, all divided by e to the power of 2x squared, e to the power of 4x. Now I've got e to the power of 2x in the numerator, so if we take it out and put brackets in, so if we factorize it, e to the power of 2x leaves us with cos x minus 2 sine x all over e to the power of 2x, e to the power of 4x rather. I'll just rub that out and write it again to make it clearer. And a red pen again. E to the power of 4x. Now we've got e to the power of 2x on the top and 4x on the bottom, so if we simplify, we have, tell you what, I'll just cancel that in. That cancels with that, leaving us with e to the power of 2x. So that's our differential. Let's just state that here. dy over dx is equal to cos x minus 2 sine x, all divided by e to the power of 2x. Okay, so we've differentiated. Now what we need is to set that differential equal to 0. Why? Because at the stationary point the gradient is equal to 0. So let's do that then. So at the stationary point, dy over dx is equal to 0, which implies then that cos x So let's say therefore at stationary point cos x minus 2 sine x all over e to the power of 2x is equal to 0. So rearranging, cross multiply, we bring the e to the power of 2x and multiplies to 0. So you end up with cos x minus 2 sine x is equal to 0. So cos x is equal to, becomes plus 2 sine x. And what I'm going to do is I'm going to divide by cos at the same time divide by 2. So I end up with a half, the 2 comes down here, is equal to sine x over cos x. So a half is equal to tan x, which we've just learned. So that means that x is equal to tan to the minus 1 of x, oops, not of x, of a half, tan to the minus 1 of a half, which is equal to 0.464 with the calculator. So we've got x, that's the value of x at the stationary point, but it wants us to find the coordinates of P. So I also need to find y. Just going to get a different color and we can work through it over here. I want the y coordinates now. So in order to find that, I'm going to try green. Let's see what happens there. We've got y is equal to sine x divided by e to the power of 2x. At the stationary point, x is equal to 0.464. So we apply that then. So y is equal to sine of 0.464 divided by e to the power of 2 times 0.464, and that's when you can just enter in your calculator. It should give you 0.177. So we've got our y coordinates and our x coordinates, so we can say that P is given by 0.464 and 0.177. So hit pause, make some notes. Once you're done with that, hit play again, and the best part, I've got some questions for you to have a go at. So you're looking at exercise 9E, and I would say, because again this is unfamiliar, it's worth doing questions 1 and 2 to become familiar. It's nice to do things with the exponential and the log in them, so that you can become more confident in using those and differentiating those. And then flip the page and we get up to question 12. Okay, so exercise 9E, good luck.